Next, we'll be solving and graphing more inequalities. In the last video, we mentioned that when you solve an inequality, it's pretty much exactly the same as the way that you solve an equation, unless you end up multiplying or dividing by a negative along the way, in which case you do one extra step of reversing the inequality sign. So let's look at this first example. A divided by 3 is less than or equal to 12. The inverse of dividing by 3 is multiplying by 3. So I'll start by multiplying both sides by 3. When you divide by 3 and then multiply by 3, you get 1, so 1a, which is just a. 12 times 3 is 36. I did not multiply or divide by a negative, so my inequality sign stays the same. When I go to graph that, my cutoff point is 36. I need one number larger and one number smaller than 36. Because there's an equal to sign here, that means that 36 is a solution, and it should be shaded, so I have a closed circle there. 35 is one of my test points. 35 is less than or equal to 36. That's true, so I do shade on the side of the 35. 37 is my other test point, and that's a false statement, so I do not shade on the side of the 37. For the next example, I'm trying to isolate the m. The inverse of multiplying by negative 4.2 would be dividing by negative 4.2. On the left-hand side, 4.2 divided by 4.2, or rather negative 4.2 divided by negative 4.2 is positive 1, so we have 1m. On the right, 6.3 divided by negative 4.2 is negative 1.5. In this problem, I did multiply or divide by a negative. I divided by a negative, so I must switch the inequality. It was a greater than, it is now a less than. When I go to make my number line, I need the negative 1.5 in the middle, and we need at least one number larger and one number smaller, such as if I were to go up by a half instead of 1, I'd be at negative 1. And then if I went down by a half, I'd be at negative 2. So you don't necessarily have to count by ones every time. You can count by other values as well. Negative 1.5 is my cutoff point. It is not a solution. Negative 1.5 is not less than negative 1.5, so I have an open circle. Negative 2 is less than negative 1.5, so I do shade on the side of the negative 2. Negative 1 is not less than negative 1.5, so I do not shade on the side of the negative 1. Let's look at two more examples. 2y minus 5 is less than 7. I'm trying to isolate the y. The inverse of subtracting 5 is adding 5. On the left, I end up with 2y. On the right, I end up with 12. The inverse of multiplying by 2 is dividing by 2. I did not multiply or divide by a negative, so I do not switch the inequality. So my cutoff point is a 6. I need one number larger and one number smaller. 6 is not a solution, so that's an open circle for my cutoff point. 5 is a solution, while 7 is not a solution. So I shade on the side of my number line with the 5, but not the side with the 7. One last example here. Now I have variables on both sides. Just like I did with equations, my first step in this case would be to rearrange the equation so that all of the x's are on one side of the equation. In this case, we're going to add 2x to both sides. And then we want all of the constants on the other side. So the inverse of subtracting 3 would be adding 3. And the inverse of multiplying by 5 is dividing by 5. I did not multiply by a negative or divide by a negative, so I don't switch my inequality sign. 3 is my cutoff point. I need at least one number smaller and one number larger. 3 is not a solution, so I have an open circle as my cutoff point. 2 is not a solution, but 4 is. So I shade on the side with the 4, but not on the side with the 2.